Okay, here we go with a volume of cross-section that looks like this. We have a quadratic, which is x squared equals 8y, which is y equals x squared over 8, which is a fairly thin, tall parabola, and the line y equals 4. So here's the base of our region, and we have cross-sections perpendicular to the y-axis that are equilateral triangles. So I need to find the base of this region, and then I know that I'm going to integrate with a constant of rad 3 over 4, which is always used for an equilateral triangle. And my limits of integration with respect to y are from 0 to 4. And I know I need a dy. So I just need to know what this distance is right here. So the way to get it is to first solve the equation for x. So x equals the square root of y. So x is 2 times the square root of 2y. That gives me just half of the base of the triangle. So I need to double that to get x equals 4 times the square root of 2y. And then I take that as the base and I square it. So if I go ahead and square this function, I end up with 4 squared, which I can bring out in front, rad 3 over 4 times 16, from 0 to 4, and the square root of 2y squared is just 2y. So this leaves me with 4 rad 3 out in front, and then I have 2y, which integrates to y squared. Oops, I better remove the integral symbol. Hold on. We go back, and my 16 times rad 3 over 4 is just 4 rad 3. 2y integrates to y squared, and I evaluate that from 0 to 4. So I end up with 4 times rad 3 times 16, which should be 64 rad 3, and it is. That's our answer, is B. So we do number 27 over here. We have e to the negative x, which has a y-intercept of 1 and is descending and looks like this. And they're talking about regions bounded by the x-axis and the y-axis and the line x equals 1. So this region here. And each section perpendicular to the x-axis is a square. So that means everything is in terms of x, and our limits of integration are just 0 to 1, so that's easy. And then the base of each square is e to the negative x, so I am squaring e to the negative x. So if I just clean that up in my writing, I have e to the negative 2x dx. And when I integrate that, I get e goes to itself, and then divide by the derivative of the inside function, which is negative 2, evaluate it from 0 to 1. So in the end, I will have e to the negative 2 over 2 minus a negative, did I do that right? I wanted e to the negative 2 over negative 2, excuse me. So that should be negative. And then minus this negative will make it go positive, e to the 0, which is 1 over 2. So let's see which one that matches. Looks like I have this guy. If I factored out a 1/2 here, I would have negative e to the negative 2 plus 1, which is in fact e.